Number 1, we know we have to factor it to solve. Megan, could you tell me which, what goes into 6x squared and 18x?
6x.
Perfect. So let's go ahead and GCF a 6x on the outside, leaving yourself just one set of parentheses. And Will, what's on the inside?
X minus 3.
Perfect. X minus 3. Now we need to use a zero product property, set each of the factors equal to 0. And we get our two answers to be 0 and 3. That one's not too hard. Now, looking at number 2, we see we have 3 terms, but each term has what? Kevin, what does each term have on number 2? Yeah, they're all divisible by a 4x. So one set of parentheses at this point. Divide each by 4x. We get x squared minus 15x. And for those of you who don't have this next one, it's 56. Now, we have such good luck that our trinomial now does not have an a term, so much easier to factor. 2 sets of parentheses. And factors of 56 that add to negative 15. Who has them? Evan. Nice. Now, it's very, oops, I wrote 2. Just kidding. It's very important to note this next fact. Often we'll divide out a number and we can disregard it. But if we factor an x out, you can't drop the x. Because in fact there are 3 solutions for this one. We have that 4x equals 0, that x minus 8 is 0, and that x minus 7 is 0. So have we just divided out a 4 and it was a different type of problem? Yeah, we could divide both sides by 4 and it wouldn't impact our solution. But when we factor a variable out, you have to consider it and when you use a zero product property. Now we have 3 solutions. One of them is 0, positive 8, and positive 7. Interesting. There are 3 solutions, and this problem's highest degree was what? 3. I wonder if there's a connection. Moving on. Or I should say questions so far. All right, Casey, what do you think I should do on number 3 first?
Factor out 7, x to the third.
I agree. Factor out a 7x to the third, one set of parentheses, and you have 2x plus 3 left, right? 7x to the third equals 0. Really what you're doing is you're dividing 0 by 7, and then you're taking the cube root of 0. Well, what times itself 3 times is 0? It's still 0. Then over on this side, 2x plus 3 is 0. Negative 3, 3 over 2, negative 3 over 2. All right, Ingrid, approach on number 4.
You can factor a 2x to the 4th.
Perfect. Katie, when I do that, what am I left with?
X squared plus 3x
Nice.
minus 40 minus 4.
Perfect. Once again, we're lucky because the trinomial we're left with does not have an a term. Griff, what do you think are factors of 40 or negative 40 that will have a difference of negative 3? Or a positive 3, rather. See, we got 40 and 1, 20 and 2, 10 and 4, last one. 8 and 5. So x and x, which one's negative and which one will be positive?
The 5. I mean, the 5 would be negative.
Oops, I put an equal sign for some reason. So you said that the 5 would be negative and the 8 would be positive. I agree. That would result in a positive difference of 3. All right, so now set each factor equal to 0. And remember, I know it seems a bit inconsequential because you could do or find the solutions without showing much work, but on a test or quiz, I'm going to want to see that you use the zero product property, that you showed the step I just wrote. All right, solutions. Positive 5, negative 8. Questions on number 4? Does it seem easier than yesterday? Yeah, I think so too. All right, turn the page over if you're working with me. Number 5 has 4 terms. Who knows what this method, the method we're going to use is called? It is the grouping one. So we need to group the first 2 together. It's already in standard form. And then I'm going to make this a plus and make that in miniature minus. That's really hard to see. So m to the third and m squared have m squared in common. And then we're going to factor out a negative 4. That way we can make this a minus 1 and they'll look the same. Alright, so each term now has an m minus 1 in common. And we're left with m squared minus 4. Ingrid, do you think we're done? What do you look at that binomial, the m squared minus 4?
No.
What type of special one is that? Perfect. Who knows how a difference of squares factors? Coleman?
Plus 2 and then minus 2.
Perfect. Square root of each of them, make one a minus, one a plus. That's the complete factorization for 5. Aaron?
How did you get the negative 4?
Well, it was originally a minus, and I marked it all up, so you can't really see on mine. I'll erase. Still can't see. So you see how that was originally a minus? And what I did is when I grouped it, I made it a plus and then made it negative 4m plus 4. And then when I undistributed, undistributed negative 4, which would make that a positive m, but I'd have to change the sign here and make that minus 1. Is that understood?
Yeah.
All right, good. All right, Chanel, what do you have for number 6? Or what should I start off with for number 6, rather?
You should do the corresponding
Which is?
Which is y squared.
Perfect. That leaves us with x squared minus 81 y squared. And now, looking at what's left in the parentheses, what type of binomial is that? Megan? It is. So that factors into what?
Y squared x plus 9y and then x minus 9.
Nice. Very nice. Number 7. Go ahead, Anna.
I'm going to answer a question on the previous one.
Okay.
Can you also have it as x? Can you have done differences squared without taking the y squared out?
Yes. So, but if you did that, what would happen? We'd have x, y minus 9y squared, x, y plus, oops, I forgot my y, x, y plus 9y squared. Yeah. Yeah. It's interesting. All right, so, okay, sorry, Anna, go ahead. Nice. M plus 4n. Yeah, at first, if you looked at 36 and you're like, oh, 36 is a perfect square. Well, the square root of 36 is 6, and 6 times 2 is 12, not 13. So watch out on number 7. All right, and last one for notes today. How many terms are there? There's 4. Must be grouping, but it's out of order, so let's put it in order. So then we have these two together, and then if I make that plus and then make this term minus, you can factor an a squared out, a plus 1, factor a negative 64 out, a plus 1 because we factored a minus, and so with each term has an a plus 1, leaving us with an a squared minus 64. Oh, we keep doing the same problem, don't we?
Yeah.
What are we left with? A difference of?
Squares.
Very nice. So we can keep this one and have a plus 8 and a minus 8. Questions? Nice job.